Hi folks, Mr. Long here. I'm just going to do a screencast on arithmetic sequences and just some simple calculations that we do with them. So we know a sequence is a pattern of numbers, and sequences have term numbers and term values. So if you look at this, this is the first term. It has a value of 11. This is the second term. It has a value of 8. This is the third term. It has a value of 5. This is also known as A, the first term value. If we look at how things change, does it have a common difference? A difference. Difference is subtraction, right? So 8 take away 11 is negative 3. 5 take away 8 is negative 3. That means the common difference is negative 3. We also know that A equals 11. And that's all we need for our formula. Because it's linear. We have a starting value of 11 and a difference of negative 3. So that means when I go to write my formula, instead of y equals, I write Tn equals. And then I go with A. In this case, A is 11. And the common difference is negative 3. Brackets n minus 1, where n is the term number. Okay? So our 11 comes from the first term value. Our negative 3 comes from the common difference. So you can read this in a way as y equals 11 minus 3 times x minus 1. Okay, let's do it for the next one. 2/3, 5/12, and 1/6. Well, that's kind of hard to do. I think we probably should get equivalent denominators. So 2/3, what's a common denominator between thirds, twelfths, and sixths? I'm pretty sure it is twelfths. So let's see. 2/3 would be the same as 8/12. 5/12, of course, is still 5/12. And 1/6 is the same as 2/12. So what's the common difference there? And this time I'll show it at the bottom. So I would do, well, this one's going to be negative as well. 2/12 minus 5/12 would be negative 3/12. 5/12 minus 8/12 would be negative 3/12. But we know that 3/12 is the same as 1/4. So D equals negative 1/4. We also know that the first term value, A, is 2/3. So our formula, if I write it here, is going to be Tn. And remember, we're going to look up here at this formula. Tn equals A plus D times n minus 1 in brackets. So Tn will equal, it's like y equals 2/3 minus 1/4 times n minus 1. Okay, and that's the formula. So all we did on this page is come up with formulas from a list of numbers in a sequence. Let's go to the next question. So this is number 2a and b, and it says find T10 for this formula. Tn equals 3 plus 4 times n minus 1. Well, T10 really means it'd be like writing f at 10, right? Sub in x equals 10 and get the value of y. So T10 equals 3 plus, so everywhere where I see a 10 in the formula, I have to substitute in 10. 3 plus 4, I'll write this, circle that 10 there. 10 minus 1, and that, of course, goes in brackets. So the 10th term value is 3. That's 10 minus 1 is 9. 9 times 4 is 36, is 39. Okay, so the 10th term value is 39. Remember, this is like your y value, and 10 is like your x value. Okay, the 10th term value is 39. The first term value was 3. The common difference is positive 4 for this case. Now, this question, it says, I want you to find T7. If A1, or A, it should say, just say A, is 3x and D is negative x. This is kind of weird. This is very abstract. So we still need to write our formula. Tn equals A plus D times n minus 1. Well, that's going to be Tn, or y, equals A is 3x, and then it's minus x, so minus x times by n minus 1. So I need to figure out what T7 is. So T7 equals 3x minus x times by 7 minus 1. So I'll circle that 7 there. So everywhere where I see n, I replace it with 7. So this now will equal 3x minus, that's worth 6. So x, negative x times 6 is minus 6x. T7 then equals negative 3x. Okay, so instead of having constants as values for A and D, you have variables, and that's perfectly fine to do. Okay, let's do another. Find the number of terms in the sequence 7, 10, 13, 55. Okay, so this is T1, which is A. This is T2, this is T3, and this, we don't know, this is Tn. It's the last term value. So let's look at our formula. Oh, it looks like plus 3, plus 3. Oh, okay, so our A value is 7, our D value is plus 3. So that makes our formula Tn A plus D times n minus 1. D is, by the way, it's like the slope. So Tn equals A, which is 7, plus 3 bracket n minus 1. So I need to solve for the number of terms. So am I solving for, which letter am I solving for? Tn, or which unknown, or n? I have to decide that. Well, the number of terms is referenced by n. N is the term number. So Tn is like the y value. Well, so what's that 55? Is that a term value or is that a term number? So if it's a term value, that's like y. A term number is like x. I'm thinking that's like a y value. So what this question really is saying is, when the y value is 55, what's x? So 55 equals, the last term in the pattern equals 7 plus 3 bracket n minus 1. So to solve this, I have to minus 7. 55 minus 7 is 48. That gets rid of that 7. 3 bracket n minus 1. Now you can expand through those brackets and solve, or you can simply divide by 3 right away. 48 divided by 3 is 16. That gets rid of that 3, and that's n minus 1. And then I add 1 to both sides. That gets rid of that, and I have n equaling 17. So that means that T17 equals 55, or there would be 17 numbers in that list. So again, I encourage you to pause it, review these again and see, but there's very clear type questions here. One more type question. Now here's this one. It says the third term value is 20, the ninth term value is 50, and we want to find the 17th term value. So the way I see it is, I've got T1 here, I don't know what that is. I've got T2, I don't know what that is. I've got T3, and it's 20. And then dot, 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 T9 is 50. So I need to figure out what A and D are. Maybe. I might not even need to figure out A and D. I maybe just need to figure out D. Let's think about this for a second. There might be some clever ways to do it. So when I go from T3 to T9, I added 6 terms. and my term values went up by 30. So from 20 to 50. So in other words, I added 30 in 6 terms. Well, that's going to tell me the difference. It's like delta y over delta x, right? So delta y is 30. Delta x goes from 3 to 9. It's 6. 30 over 6 is 5. That's the common difference. So there's something here that might help us. I know that T9 is 50. Do I even have to rewrite the formula? Because take a look at this. I'm supposed to find T17. Well, if I know that T9 is 50, T17, how many more times am I going to have to add 5? To go from 9 to 17 is 8 more times. So I'm going to have to start at 50, and I'm going to have to add 5, 9 and 17, 8 more times. 5 times 8 is 40, plus 50 is 90. Therefore, T17 is 90. Now, I did that in a bit of a tricky way, though, right? So I want you to go back over that. T9 was 50. I wanted to figure out T17. So that means I have to add on 17 minus 9, which is 8 more terms. What's each term value going up by? 5. So that means I start at 50, and I add 5 a total of 8 times to go from 9 to 17. 50 plus 40 is 90. T17 is 90. So what you've seen in this video are all the different types of arithmetic sequence questions that I'm going to ask you. And so you'll need to go over these, if you perhaps, and work through some homework questions that I will assign. And those will be posted as well. Hope you have a good night. See you tomorrow.